So let's take a look at this last application problem in preparation for our upcoming test. We have a hot air balloon is floating at an altitude of 300 meters above a straight highway. Looking left, the aviator notices a car at an angle of depression of 30 degrees. That should say of 30 degrees, not on 30 degrees. To his right, a car is seen at an angle of depression of 22 degrees. What is the distance between the cars? So let's draw a picture of what we have going on here. Let's draw our road, and on this road we have a car here, we have a car over here, and we're wanting to find the distance between those cars. Up above the road at 300 meters we have a hot air balloon. So let's draw just the horizon. If the aviator in the balloon is just looking straight ahead parallel to the ground, we have this. But the looking left, you have an angle of depression of 30 degrees. So you're tilting your head down 30 degrees to see the car. Two parallel lines cut by transversal alternate interior angles are congruent, so that must be 30 degrees. When you look to your right, you see another car over here, and there you only had to have an angle depression of 22 degrees. So this is 22 degrees. Now the height of the balloon, I forgot to put that as 300 meters. So let's come in and work with this right triangle and find this distance from the car to directly underneath the balloon, and then we'll come in and work with this other right triangle. And we don't have symmetry with the 30 and 22, so we can't say that it's X. So I'm just going to say that it's Y. It doesn't really matter. The distance between from the car from here to here is going to be X plus Y. Is going to be our final answer. So on the left here, the tangent of 30 degrees. I need this picture, but I also need to shrink it up. And it doesn't like it when you shrink up these. See how that distorts the. It didn't, but if I come in here and copy and paste, it'll treat this as an entire image, and I can shrink it up and it doesn't distort it. Okay, so the triangle I've highlighted in yellow, the tangent of 30 degrees is equal to 300, the opposite leg divided by the adjacent leg x, and this is x is equal to 300 divided by the tangent of 30 degrees. Over here on the right, if I take the tangent of 22 degrees, that's 300, but this time the opposite leg, this time divided by y. So that's y is 300 divided by the tangent of 22. The distance between the cars, if we call that d, we just add these up. So let's just jump to a calculator. Double check that we're in degrees, that we're rounding to the nearest hundredth. So we've got it set up right. So we've got 300 divided by the tangent of 30. I want to close that parenthesis, and then I want to add 300 divided by the tangent of, what was it, 22? Yeah. So I say that the cars 1,262.4 meters apart from each other because the units was meters. So that's my final answer. Hey, I hope that helps, and I'll talk to you later.